Hello, this is a social housing retrofit accelerator masterclass on MMR, Manufactured Methods of Retrofit. My name's Elle George and I'm from Elevate. I'm a civil and environmental engineer specialising in sustainable design and construction. I'm a big advocate for the use of innovative construction methods to improve outcomes for all. Modern methods of construction offer systemised approaches to whole house retrofit, and of course, whole house retrofit delivers significant improvements in energy performance, lower bills, and comfort. I'm going to explain how manufacturing can offer faster, scalable solutions suitable for most building types. Residents can typically remain in their homes as interventions are designed around occupants, reducing costs and disruption. In this session, we will explore some of the market leaders of systemised approaches and why registered providers of social housing need to embrace digital and industrialised solutions to achieve the scale, quality and cost reductions we need in this retrofit challenge. This course is aimed at those who are seeking to understand and know more about MMC, to allow you to have the confidence to specify the increased use of these techniques. The topics covered will be an explanation of the terminology used and how these techniques could be applied to retrofit, the advantages of using these methods, the MMC definition framework, some examples of the framework in practice and the practical application for industrialised retrofit. As this is a rapidly evolving sector, some of it is what is already happening and some of it is what you could expect to see in the coming months and years. So let's start with some acronyms. Hopefully you know MMC is Modern Methods of Construction. Probably heard of that one. MMR is Manufactured Methods of Retrofit. OSM and OSC are Off-Site Manufacturing and Construction respectively. Design for Manufacturing and Assembly, known as DfMA, is an engineering methodology that focuses on reducing time to market and total production costs by prioritising both the ease of manufacture for the product's parts and the simplified assembly of those parts into the final product. PDfMA is adding P for platform to DfMA. I'm going to go into more detail about this, and PMV, pre-manufactured value. Design for Manufacture and Assembly is a design approach that focuses on ease of manufacture and efficiency of assembly. The theory is that by simplifying the design of a product, it's possible to manufacture and assemble it more efficiently in the minimum time and at lower cost. Traditionally, DfMA has been applied to sectors such as the design of automotive and consumer products, both of which need to efficiently produce high-quality products in large numbers. More recently, construction contractors have begun to adopt DfMA for the off-site prefabrication of construction components, such as concrete floor slabs, structural columns and beams, and so on. You're hopefully familiar with this image, but I'm not expecting you to be able to read it, but hopefully you can recognise that it is the RIBA plan of work. Produced by a group of off-site industry experts and first published in 2016, the DfMA overlay to the RIBA plan of work is a project management guide when implementing modern methods of construction. The new edition was released 1 year ago and is based on 5 years of evolution, including the launch of the definition of the 7 categories of modern methods of construction, which we'll cover in a moment, and aligns with the RIBA plan of work 2020. You can download the DfMA overlay to the RIBA plan of work using the link on the screen. The supporting report sets out drivers of change towards a manufacturing mindset, as well as explaining why a DfMA approach must be adopted as a default to fulfil the outcomes our industry needs to achieve. It doesn't alter the foundations of good design and production, which are about getting the best possible outcomes for clients and communities. The DfMA overlay to the RIBA plan of work aims to dispel the myth that DfMA is a barrier to great architecture or reserved just for new build. There are few limits on where it can be applied, so the good news is that DfMA can be applied to your retrofit projects on existing buildings. I've pulled out one example of the guidance in the green box, and this is actually key to the success of embedding manufactured solutions into any project. It is that appropriate MMC solutions should be identified at the concept design stage, REBA stage 2, to ensure that, for example, the cost plan and health and safety strategies consider DfMA and liaise with the wider supply chain as required. You might also just about read in the circle it says to appoint an MMC advisor at stage 0. It really is vital to understand this requirement for early engagement, considering MMC strategies right at the outset. Adding P to make PDfMA is all about creating platform approaches. You might have heard of the term kit of parts approach. Product platforms are a collection of parts that are common to a number of products. All platforms have 3 common elements. These are a set of low variety core assets, and these common assets are typically physical components, but may also include repeated processes, which is the case for digital platforms. The common assets are replicated multiple times, enabling platform owners to gain competitive advantage by enhancing production or delivery efficiency. Secondly, a complementary set of peripheral components that exhibit high variety. The use of interchangeable peripheral components results in a diversity that creates distinctive offerings to the market. Third is a stable interface that acts as a bridge between the stable core and the variable peripherals, permitting both innovation in the core and peripherals. Plus, we need a set of rules or standards governing how the components can be integrated. Strategically leveraging the benefits of commonality, platforms have been successfully applied across a variety of industries to deliver mass customized products, affording customers with a variety of choice whilst maintaining an efficient and effective method of production. Platforms are not yet prevalent in retrofit, although some discussions are taking place. But as the market grows, it is vital that industry coordinates so that true benefits of DfMA can be realised. The Construction Innovation Hub's platform rulebook link is on the screen. To quickly provide a bit more context on how platforms are already applied and the potential for retrofit industry transformation, I have some examples of both physical platforms and digital platforms. On the left, an example from the platform rulebook of a physical platform. This range of trainers is an example of a product platform. Low variety common assets, all produced in the same way, make up the majority of each shoe. Stable interfaces and peripheral components allow the inclusion of different soles, laces, and colour finishes for a high degree of customization. Car manufacturers use this same concept of product platforms where the chassis, or core, tends to be fixed, with customers able to select a variety of colours and other additional extras, the peripherals. On the right are examples of digital platforms. Whether it was Airbnb to hospitality, Amazon to retail, or Uber to personal transport, these sectors have been completely transformed by disruptive digital platform solutions. Digital transformation can be a catalyst to solving some of the issues our sector is facing. Housing and wider construction should take advantage of the benefits of platforms. I hope that both physical and digital platforms can transform the playing field, allowing the deployment of low energy, high quality, healthy homes. Russell Smith has a deep dive into digital solutions for retrofit, especially talking about building passports, so do check that out. The use of pre-manufactured value, or PMV, is a key industry metric for measuring progress towards modernisation. Just like understanding our building performance gap, we know measuring PMV is a vital element to driving behavioural change towards the use of more sustainable manufactured methods. PMV is a means of measuring industry improvement through a direct link to the physical way in which a building is constructed. It is effectively a scoring mechanism for enabling DfMA. PMV was first set out in the Pharma Review in 2016. More on that in a moment. as a metric to measure the proportion of manufactured components within an overall construction project cost. The metric, expressed as a percentage, is intended to identify how far projects are implementing innovative construction techniques that result in reduced site labour and prelims. On the new build side, the government has introduced PMV as a central plank to its Affordable Homes programme. Under this, 25% of funded projects must be delivered using MMC. Homes will only be classed as MMC if they have a PMV score of 55% or more. PMV provides a framework for measuring progress, and we're expecting that we'll see its use across more policies in the future, so it's good to get to grips with how it works now. Gazing into my crystal ball, I predict that there will be something similar introduced for government-funded MMR retrofit programs, but I expect the percentage requirement to be lower, and of course the market needs to be more established. Policymakers, both at national and regional level, can use the PMV metric to create positive change for the construction industry and indeed society in line with broader policy objectives. There is increased industry focus on moving to outcome and value-based procurement, as advocated in the 2020 Construction Playbook and other ongoing public sector procurement reforms. And this leads me on to the benefits of manufacturing for retrofit. I won't dwell on this because the benefits of manufacturing are well publicised, and you can probably go to many events and webinars covering this. But specifically for the retrofit market, there is an improved speed of construction, and this can be of great benefit to the homeowners or tenants because they face less disruption to their homes and lives. Manufacturing in a controlled environment means it's possible to focus on a high quality product, and this is absolutely essential if we're to avoid creating a performance gap between the designed for and the as-built scenarios. And of course, off-site approaches can also further reduce the carbon emission, what we're trying to reduce in the first place from retrofitting, reduce the carbon emissions from being built in a controlled factory environment. And there's also increased predictability of outcomes, including cost certainty. Another main benefit are around the reduction in the amount of waste generated. And by that, I don't just mean wasted resources, but also wasted time that is taken up in the process by retrofitting homes in a more traditional way. Manufacturing also reduces health and safety risks. There are actually other social value-based outcomes that off-site manufacturing and MMC more broadly bring that are less well documented. I'm not going to go in depth on this either, as there's already a masterclass embedding social value in retrofit projects by Sarah Daly. You might have heard of the Construction Innovation Hub's Value Toolkit. This is a significant step forward towards the adoption of an outcome-based approach to delivery across the construction industry. You can see here the value outcomes of utilising MMC mapped on a 4 capitals model, these being social, human, natural and produce benefits. The toolkit supports better decision making throughout the whole investment cycle, from business case through to procurement and delivery and operation, improving overall sector performance consistent with key policy objectives such as driving MMC, delivering social impact and accelerating the path towards net zero. MMC is a central concept of the UK government's recently published construction playbook. And in this, it sets out a new longer-term output-focused approach to contracting for public works. It can also help drive the UK government's levelling up agenda, as production can be located away from centres of demand in the South East to access valuable manufacturing skills in other regions and widen employment across the country. This is true for both retrofit and new build. From an industry perspective, there's now greater confidence and positivity about the role of modern methods of construction, but the challenge is to work out how UK government policies can work in tandem with the construction industry supply chain to deliver long-term structural change. And it's fair to say that the markets for off-site approaches are still in relative infancy, and even more so for retrofit products. The UK government, is the largest buyer of construction services in the UK. Although there has been a presumption in favour for government departments using MMC to procure housing, schools, hospitals and infrastructure, more needs to be done to accelerate the use of MMC by government. The approach of Homes England I mentioned earlier, using PMV metric, provides an example to follow. By mandating the use of MMC in schemes and providing funding to MMC suppliers, it has sought to create volume certainty and improve the working position of MMC product suppliers. There are real valid concerns, though, about the availability of the labour workforce to deliver the massive task of retrofitting thousands of homes. Mark Farmer, who's pictured, raised these issues in his report, Modernise or Die, in 2016. There's a clip on the right-hand side of some of the problems in the sector. Off-site construction is a key strategy to address the workforce availability issues facing our sector. Mark Farmer and his team at specialist consultancy CAST were heavily involved in the development of the MMC definition framework. This definition framework intends to regularise and refine the term MMC by defining the broad spectrum of innovative construction techniques being applied in the residential market, both now and in the future. As well as bringing regularised terminology, the framework also offers the opportunity to create more structured datasets, capturing the use of MMC and its performance. So enabling designers, clients, advisors, lenders and investors, warranty providers, building insurers and valuers to all build a common understanding of the different forms of MMC. It's a spectrum, where category 1 refers to buildings which are almost completely constructed off-site, through to categories 6 and 7, which involve site-based process improvement measures. The next part of this session will involve understanding more about these different categories, definitions 1 through to 7, and how they could be applied to the retrofit sector. And then following this, I'll give you some specific examples of panel manufacturers and how they're able to respond to various archetypes. Before we dive into the definitions in more detail, let's just address a couple of common misconceptions. Firstly, there is sometimes the assumption that manufactured off-site elements use different materials. Exactly the same as any building site, they use primarily steel and timber. LGS, or light gauge steel, and HRS, hot rolled steel, are common, or timber mainly in the forms of structurally insulated panels, timber frames, glulam beams, or CLT, which is cross-laminated timber, or plywood. It's important to remember that manufacturing is about the process. This process brings about better accuracy and quality control, among the other benefits that I've already touched on. It's not always cheaper, not yet anyway. The industry needs to scale in order for it to be cheaper, and anyway, these days we're talking much more about value-based outcomes rather than the drive for the lowest possible price. And finally, probably the biggest misconception is that when you say the term off-site, many think it refers to the pictures that you can see on your screen now. And if you Google what is off-site construction, these are probably the images that you'll see. Both of these are examples of new build category 1, also known as a volumetric off-site. But as you'll see on the next slide, there's actually a lot more to it than volumetric boxes. So firstly, let's cover category 1, 3D primary structural systems, often referred to as volumetric. The creation of 3D volumes, boxes effectively, away from site, which are then combined on site to create a building. Now you might be thinking that this category is completely irrelevant to retrofit, but actually that's not the case if we consider the opportunity to use what has been termed as airspace development, or building up upon the roof. Several examples are shown on the screen now. Knight Frank estimates that 40,000 homes could be built on top of existing buildings in central London alone. Now, in terms of retrofit, this could be combined with improvement of the building itself, alongside an increase in accommodation on the roof using lightweight structures. Category 2 is the creation of 2D panelised and framing systems away from site that are assembled on site to improve the structure of the building. There's a range in the extent of pre-manufacture. So three types, and these are based on the amount of completeness of the panel system. So 2A is the frame only, and typically these are walls, floors, roofs and stairs. Type 2B is the frame plus insulation. And type 2C is the same as 2B, but also includes doors, windows and external cladding, all added in the factory. Typical systems use light gauge steel and timber frame. Category 3. These are non-systemised structures in mass engineered timber, hot or cold rolled steel and precast concrete elements. Applications tend to be in the new build, for elements like load-bearing columns, walls, staircases, slabs, ring beams and pile caps. The main application in retrofit, that I know of at least, is pre-manufactured roof modules. This example shown is a new building, but this approach could be utilised for retrofit, particularly where the roof is in very bad condition and a whole new roof needs to be specified. Category 4 is additive manufacturing, commonly known as 3D printing. In terms of housing, you might have seen videos or images of whole homes being 3D printed in concrete, like the top right picture. But the relevant application in retrofit is much more likely to be 3D printing of bespoke components or attachments that could be used in combination with category 2, 3 or 5. I think this is particularly exciting in the sense that it could allow for homes to be scanned using digital methods and then individual components being 3D printed to attach a generic peripheral component like a panel, for example. This combination of MMC categories using platform approaches is where I believe there's a huge scope for retrofit to be industrialised. Category 5 is about non-structural assemblies and sub-assemblies. It is the use of pre-assembled components that do not form the structure of the building, but which can consolidate materials and processes that otherwise would be delivered on site. These solutions can be used in isolation in an otherwise traditionally constructed project and include reasonably common elements, such as bathroom or energy modules or pods. There are two overarching types of component: 3D, i.e. pods, or 2D, like facades, risers and door sets, and in total there are 12 types as listed on the screen. I've highlighted in bold the subcategories which are most likely to be utilised in MMR, manufactured methods of retrofit. The image is of a pre-manufactured energy pod by a Dutch company called Factory Zero. This is an example of a mechanical and electrical pod, or you might call it a prefabricated utility cupboard. You can see that I've highlighted 5K wall cassette. These shouldn't be confused with category 2, panel systems. 5K are non-structural wall systems, whereas category 2 refers to structural elements. And in a moment, I'm going to explain further how these different panel solutions could be applied to various archetypes for retrofit. Just dwelling a bit longer on this category because it's probably the one with the most potential applications for retrofit, and I've provided some examples on the screen here. At the top you can see the Yes porch by Bowtie, which is basically an energy module and a new porch combined into one pre-manufactured pod. Another good example are these 2D plumbing manifolds by Elements Europe. And you can imagine the time and materials that could be saved for this new equipment being assembled in a controlled environment rather than in individual homes. On the bottom right, you can see a manufacturing line for bathroom pods for a new build project. I know of a project where several homes in need of retrofitting have ground floor bathrooms at the back of the building. They're generally in a bad state of repair and need replacing. New bathroom pods fitted with insulated facades would be a good solution in this instant, but the key requirement is to make it worthwhile for the manufacturer, and that's volume. It would not be feasible to set up a manufacturing line for a handful of this type of product. But where you can aggregate similar homes into, say, tens or hundreds of the same type, this becomes possible. Not every single one would need to be the same, especially if we employ platform approaches and 3D printed components to allow small tolerances where each home is slightly different. Hopefully this helps to provide a case for collaborating with other landlords to innovate together and solve these challenges. Moving on to the site-based improvements of categories 6 and 7, these relate to building product and site process productivity improvements, respectively. 6 is basically the evolution of traditional building materials so they're quicker, easier and safer to install. This can typically involve either large format versions of traditional materials or materials that have been developed to be easier to install with less reliance on site labour. Good examples of Cat 6 that are applicable to retrofit include the image on the bottom left, site-applied brick slips, all these modular integrated solar roof tiles by New Lock Roofing shown on this church. Category 7 is the use of systems and processes on site to drive productivity by removing unnecessary work stages, enabling better and faster installation and improving health and safety. This is the category with the largest breadth of options, and the list is likely to grow. The opportunities for digital integration with retrofit projects offers huge scope, and as I mentioned, this has been covered by Russell Smith in another deep dive session. 7G is the use of robotics, and this example on screen is the Qbot, which can go under a suspended floor and install insulation via a spray gun with real-time images projected back to the robot handler. Digital scanning and the use of drones would also be covered by this category. Like most of the other categories, these solutions can be used in isolation or in combination with any of the other strategies. You might have heard of Energiesprong, which means energy leap in Dutch. And the reason I'm talking about Energiesprong is that they have really pioneered the use of industrializing retrofit in the Netherlands by creating what is now an established offsite retrofit market of energy modules, insulated roofs with integrated solar tiles, and prefabricated insulated facades. There is also now an Energiesprong market development team here in the UK, which I am a member of, and one of my key roles at Energiesprong is to help develop the off-site retrofit market in partnership with the second-tier supply chain. At Energiesprong, off-site construction is one of the key principles for scaling up deep retrofit in the UK, aiming to make it more cost-effective and quicker to install. The Melius Homes team have been using the Energiesprong approach since 2015 and built the first Energiesprong projects in the UK. At least 60 Energiesprong retrofits have been completed using off-site manufacture, and around 90 homes are in progress using panels manufactured in their Nottingham facility. These particular panels are timber frames being hung from solid brick archetypes. Therefore, they are non-structural or category 5. However, Melius can also manufacture structural panels, which would be category 2. Innovare are a SIP or structurally insulated panel manufacturer based near Coventry. They're currently heavily involved in the new build sector, especially delivering schools and healthcare buildings. However, they've been working closely with the Osborne Group to develop new products, but based on these existing manufacturing techniques that they already have in place in their factory. Innovare are developing both structural and non-structural panels, so Cat 2 and 5, depending on the archetype. Their panel systems can be clad in brick effect carrier board to match the original design of the building to retain the character of the street. They're working on both smaller format timber SIPs that can be delivered in flat pack form and site assembled, and larger fully constructed facades that can be lifted into place by crane. Beattie Passive are another manufacturer that are also heavily involved in the new build sector, but are more prevalent in residential. But they do already have some experience delivering retrofit projects and have created the T-Cozy framing system. This unique system is an off-site manufactured frame, including windows and doors installed, injected with cavity wall insulation on site to create a continuous envelope around the building. The images at the top are examples of cross-wall archetypes requiring category 2 structural panels because they are needed to span across the entire front of the existing homes. Hopefully these brief examples can demonstrate that measuring and understanding archetypes at the start and identifying opportunities for manufactured methods of retrofit early on are crucial to successful adoption. We know that off-site construction won't work for everything, so it needs to, for now at least, be focused on the properties which are easiest to retrofit with standardized solutions. For example, homes without complex details or homes where this is a significant volume of very similar properties or archetypes. If you have any questions about this topic, you can contact me using the email on the screen. Thanks.